Doing the angle side angle triangle congruence theorem, often abbreviated as ASA. So in our previous section, we talked about how corresponding parts of congruent triangles are congruent and how we can use the converse of that to prove that two triangles are congruent. For example, we could prove using the fact that this angle is congruent to that angle, this angle is congruent to this angle, this one is congruent to this one, and then the corresponding sides, if all the corresponding sides are congruent, then these two triangles are congruent, right? This proof requires that we have 6 pieces of information. And a lot of you guys looked at these triangles and thought, oh, I don't really need all this information. I can just tell they're congruent because it's easier, blah, blah, blah. And there are some shortcuts. And one of those shortcuts we're going to learn is angle side angle. So we learned this brute force method because we're going to use that brute force method to do other proofs and to prove these, for example. But also we want to just kind of lay a foundation to some of these shortcut methods. So angle side angle just requires a single angle, a single side, and a single angle, or sorry, a single pair of each of those to be congruent to the other corresponding triangle. So here are some examples. I built these using a program called GeoGebra. And if we look at this triangle here on the left, you can tell it's much bigger than the one on the right. And I have fixed these angles. So this angle here is 60 degrees. This angle here is 50 degrees. This one's 60. This one's 50. And a lot of you might realize, oh, well, if this one has a 60 degree angle and a 50 degree angle, this angle up here is going to be 70 degrees, right? Same deal with this one. This one here will also have a 70 degree angle. So I don't have to actually fix that angle because it's already just fixed given the nature of triangles. Similarly, this one's fixed as well. I also put a value down here. The labels are a little weird, but the number here just represents the length of this segment. In this case, A to B. In this case, D to E. So the length of this segment is much larger than the length of this segment, and that makes sense because the triangle's bigger. A lot of you would notice that, oh, hey, congruence means the same size and the same shape. So the shape is actually the exact same. The triangles are the same shape. This one's just a lot bigger. We'll get into more detail on that sort of thing later, but for right now, in order for these guys to be congruent, I'm going to need to shrink it down until it's the same size as this triangle here on the right. So I'm going to shrink it down. At which point is it going to be congruent? Well, it's actually going to be congruent when this segment, AB, is congruent to segment DE here on the right. So since it gives the value, I can simply shrink it until that value matches up. I'm going to try and get as close as I can. If I can't, this could be lost cause. Oh, nope, got it. Okay. So it's the same value here. Now I can ask myself, well, are these two triangles congruent? And I can look up. I don't have a good way to prove they're congruent, except I threw up the area here. So we can look at the area. This area is 12.69. This area is 12.72. Why is it different? Why does it have to be different? I think it's mostly an artifact here, I think, of just the calculations. You'll get slightly different values depending on exactly what angle you put it at and such. Well, maybe not. We can zoom in a little bit more. No. 12 closer. It's only off by a little bit. So relatively congruent. Same size, same shape. And all we did now was fix 2 of the angles, and we fixed that segment in between. So we can go back to our thing here. And this is our angle side angle triangle congruence theorem. It says if 2 angles and the included side, note here, this is a new term, included. Included, most of you have figured out by now, means if I know that angle and its corresponding angle are congruent, and this angle and its corresponding angle are congruent. The included side here is the side between those 2 angles. So it's the one in between. As you go around a triangle, you will hit a side, and then an angle, and then a side, and then an angle, and then a side, and then an angle. It's like weird triangle. And so another way to think of this is to look at the name itself. It's angle, side, angle. This S, this side, is in between the two A's. So we have to have that side in between our two angles. And here I mean directly in between, bordering in between these two angles. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Remember, this is our shortcut to proving that the two triangles are congruent. We'll do some examples. Here's example A. We have triangle ABC and triangle DEF. We know that this triangle here is going to add up to 180, just like this triangle here. So we should be able to find these missing pieces, right? In addition, we can kind of figure out which angles are supposed to correspond with which other angles. This 61 degrees probably matches up with this 61. This 74 here doesn't match up with either of these. So if these triangles need to be congruent, it needs to match up with B here. Similarly, the 45-degree angle here needs to correspond with angle D, because it can't correspond with E or F if the triangles want to be congruent. So this simply asks us to find angle D first. We can do that using math. 180 minus 74 minus 61 brings us up to 45. So angle D is 45 degrees. I can go ahead and label that. 45 degrees. Now we can just ask, okay, are these two triangles congruent? And remember, now we don't have to find all 6 pieces of information. We don't have to find all the side lengths. We just need one pair of angles, one pair of sides, and one other pair of angles where it's that side is the included side between the two angles. So I have an angle here, I have an angle here, I have a side here, I have a side here, and I have an angle here and an angle here. So that's all the information I need to know. A and D are both 45 degrees. AC and DF are both 2.3, and angle C and angle F are both 61. So I can tell you that these two triangles are congruent using the what theorem? The angle, side angle, triangle congruence theorem. I'd be happy if you just abbreviated ASA. We'll have other acronyms here in the next couple chapters. Okay, let's try this one. Same sort of deal. We can look at these guys and go, oh, this angle should probably correspond with this one. This 38-degree one probably corresponds with K. If it doesn't, then they're automatically not congruent. So we need to figure out what angle P is, right? We can see if angle P matches up with any of these guys. So again, we can punch in our values here. M is 31. N is 38. That gives us a total of 69. So therefore, the measure of angle P equals 111. Now let's see, are any of these angles over here 111 degrees? Well, this one isn't 111. If you do the math, K isn't 111, so none of these work, right? None of the measures, actually, or none of, we'll switch it around the other way, since we've already got the calculation. Do any of them match up to angle L? Are any of them 110 degrees? No, none of these are 110 degrees. Therefore, we can't make this congruent. Remember, we just need a single corresponding part to not be congruent in order to say that the two triangles are congruent. So in this case, we know that angle L doesn't match up with any of the angles over here. So therefore, the two triangles can't be congruent. So we can say it is not congruent. Okay, it says in part B, do you need to find the measure of angle K? No, you don't, because we said we can simply check this angle here, angle L, against all of the potentially corresponding angles over here in triangle MNP, NMP. Okay, go ahead and see if you can do 5 and 6. So pause here. For number 5, we have two triangles. We have ABD and ACD. We know that this side corresponds with this side. This angle is congruent to this angle. And then this one is 90, but remember that is also notation for perpendicular lines. So since BC looks like a straight line, it is a straight line. AD is perpendicular, therefore it's going to be a 90-degree angle on both sides. We can figure all that out just from the image, and then we can use angle side angle to figure out that these two triangles are congruent. Then we can come over here. We can do kind of their same sort of deal. We have a 38-degree angle. Well, that probably corresponds with this one. We have this 1-incher, so that's here. Let's go ahead and figure out what this angle is. We have 38 plus 72 is 110. So that means this is 70 degrees. Are any of these angles over here 67? No. Therefore, we can simply conclude that these two triangles are not congruent, because none of these angles correspond. Well, some may correspond, but they're not congruent to angle U here. Okay, I'm going to pause right here and do a separate video for some of these proofs, just to break things up. If you feel you're confident with proofs, don't worry about them. If you want more practice on proofs, go ahead and watch these other proof videos. But this is it for the basic information. Thanks.